All right, what is your favorite GPCR?
I started out by working on the adrenergic receptors, which was great because these receptors have so many different ligands and they're so well characterized. But then I started working on a receptor that I found even more fascinating, which was the glucagon-like peptide 1 receptor. So these GLP-1R, the incretin receptors. And I think there's multiple reasons why I think that's a very fascinating receptor. The foremost reason was that when we started using that receptor in my lab, we found that we were mapping the location of the receptor at the plasma membrane, and we found it had these very distinct domains. And then when we added GLP-1, which is the native ligand, we saw a complete redistribution of where the receptors were locating. And first off, we did not expect that. And secondly, it really suggested that changing the conformation of the receptor was altering its preference for certain lipids, for certain curvatures, for certain tension, any kind of property of that plasma membrane. And so that was really a breakthrough moment kind of in my PhD, which was very unexpected but extremely fascinating. And then I think the other reason that I'm so interested in GLP-1R is, well, nowadays a lot of people are interested in GLP-1R.
Everybody is, yeah.
But I think there's like an interesting history to GLP-1R and to its discovery. I think in the 80s, GLP-1 was discovered for the first time, but actually it took a long time before we got from using GLP-1 as an actual drug nowadays, because the biggest problem with GLP-1 is that the two N-terminal amino acids get cleaved off by a protease, and so it had a very short lifetime in humans. And it actually took a long time before GLP-1 could be used. And nowadays we have these ligands like semaglutide or liraglutide that look a bit like GLP-1, but somehow they produce very different and they are very efficient in terms of agonistic properties. And so to me, it's interesting to understand how is it possible, or like, first of all, why do these peptides work as they do? But also, for example, why do dual agonists that target GLP-1R and, for example, the GIPR, you have these like tirzepatide, how is it possible that dual agonism or like triple agonism can give you very different effects or very new effects or reduce side effects, right?
Yeah.
So I would really like to understand this from a more molecular perspective, even though we do already know a lot about GLP-1R. I mean, there's like 40 years of research, and